Welcome to the Deep Dive, your shortcut to getting up to speed. Today, we're jumping into something many of you have asked about, Kubernetes. You might see it written as K-ACE. It's just shorthand for the 8 letters between K and A's. Kind of neat. Anyway, our goal today isn't just to define it. We want to really peel back the layers on Kubernetes, go past the buzzword, and figure out why it caused such a huge shift in how we build and manage software. So by the end of this, you should feel, well, pretty comfortable with the core ideas and why it's actually significant.
Yeah, and at its heart, Kubernetes, well, it's an open source platform. Its main job is automating deployment, scaling, that sort of thing for what we call containerized applications. One source actually used a really neat analogy, thinking of Kubernetes like an orchestra conductor. It's not playing the instruments, but it's making sure all the different parts, the applications, work together smoothly, efficiently.
That's a helpful image. An orchestra conductor. Okay. But to really get how this conductor works, we probably need to meet the players, right? What are the actual pieces that Kubernetes is managing? What are the building blocks?
Exactly, good question. So first up, you have containers. You can picture these like sealed boxes. Inside each box is everything an application needs to run the code, libraries, configurations, the whole deal.
Yeah.
Just make sure it runs the same everywhere, your laptop, a giant data center. It doesn't matter. And Docker, that's a popular tool people use to build these containers.
Hold on. So you're saying it basically gets rid of that "it works on my machine" nightmare? I mean, that alone sounds like a massive deal for development teams, right?
It really, really does. It's a huge part of the appeal. Now, within Kubernetes itself, the smallest thing you can actually deploy is called a pod. Think of a pod like a small group, maybe one or more containers, that live together. They share resources like storage and networking, and they always run on the same machine. Usually a pod runs just one instance of your application.
Okay, so pods contain the containers.
Right. And these pods, they live on nodes. A node is just a machine, could be physical hardware in a server room or a virtual machine in the cloud. And when you have a bunch of these nodes working together, managed by Kubernetes, that's your cluster.
Cluster. Got it. Set of nodes.
Yep. Then you've got the control plane. This is basically the brain. It makes all the decisions for the cluster, scheduling pods onto nodes, keeping an eye on their health, making sure everything running matches the state you want it to be in.
The brain. Okay.
And then deployments. These are like the instructions you give to Kubernetes. You tell it how you want your application managed, like how many copies or replicas of a pod should be running, and crucially, how to update them safely when you have new code.
So if I push out a new version of my app, the deployment handles rolling that out without me having to, manually stop and start things.
Precisely. You just update the deployment definition, and Kubernetes orchestrates the whole update process. Rolling updates, canary releases, it handles that complexity. And one last key piece, services. Services are like a stable address, a reliable way to talk to your pods. Pods can come and go, their internal addresses might change, but the service provides a consistent endpoint so other apps or users outside the cluster can always reach your application.
Okay, that gives us a good map of the territory: containers, pods, nodes, cluster, control plane, deployment services. Makes sense. But now let's get into the why. Why did Kubernetes become so dominant? To really appreciate it, we need to look back, right? What was so bad about the old ways? What were developers and ops teams struggling with before this conductor showed up?
Oh, it was. Well, let's just say challenging. Imagine trying to build something complex, but every single piece had to be manually put together, configured by hand, every single time you deployed. It led to some major headaches. First, just the sheer manual configuration, setting up servers, installing the right libraries, configuring networks, all done by hand. It took ages, and it was incredibly easy to make mistakes. Typos, missteps. Yeah.
And I bet that led straight into the second big one I've heard about, inconsistency. That whole works on my machine thing.
Exactly. It was a constant battle. An application might run perfectly fine on a developer's laptop, but then behave totally differently in the testing environment, or worse, in production, because maybe the OS version was slightly different or a library wasn't quite the same. Debugging that was a nightmare.
Right, I can imagine.
Then you had scaling issues. Let's say your website suddenly got popular. Handling that extra traffic meant manually provisioning new servers, configuring them, adding them to the load balancer. It was slow, often required downtime, and put immense pressure on the operations teams.
Right, scrambling to keep things up.
Which in turn often led to resource waste. Because scaling was so hard and slow, companies would often just buy way more servers than they usually needed just in case traffic spiked. So most of the time, a lot of expensive hardware was just sitting there underutilized, not very efficient.
Paying for capacity you rarely used.
Precisely. And finally, failure recovery. If a server died, and servers do die, getting the applications that were running on it back online somewhere else was often a slow, manual process. More scrambling, more potential data loss, more downtime.
Wow. Okay, so painting that picture, it sounds like the old way was just fundamentally brittle. Difficult to manage, hard to scale, prone to errors. Is that fair?
That's absolutely fair. Brittle is a good word. It was complex, risky, and soaked up huge amounts of time and effort just keeping things running, let alone improving them. And this is where Kubernetes really comes in, addressing each of those pain points head on, mostly through containers and, crucially, automation.
Right, so how does it fix things?
Well, take portability, because containers package everything up. That whole "it works on my machine" problem largely disappears. The container runs the same everywhere. Then, automation. This is huge. Kubernetes automates the deployment, the scaling, load balancing updates, all those manual tasks we talked about.
Takes the human error out of it too, I suppose.
A lot of it, yes. And scalability. If traffic increases, Kubernetes can automatically spin up more pods to handle the load. When traffic drops, it can scale back down, all based on rules you define. No frantic manual scaling. And maybe the most impressive part, resilience or self-healing. This is really cool. If a pod crashes, or even if an entire node goes offline, Kubernetes notices and automatically starts replacement pods on healthy nodes. It tries to maintain your desired state without needing a human to intervene immediately.
That self-healing really does sound like magic. Is it always that smooth, or are there, nuances to making that work well?
It's generally very robust, but yeah, there's a nuance. Your application needs to be designed for it, ideally stateless, so that losing one instance isn't catastrophic. There's definitely a learning curve in designing apps that fully leverage Kubernetes resilience features. But when you do, it's incredibly powerful. And finally, efficiency. By packing pods onto nodes intelligently, Kubernetes helps ensure you're actually using the server resources you're paying for, reducing that waste we talked about.
Okay, so it automates, makes things portable, scalable, resilient, and more efficient.
Yeah.
Let's tie this back together. What are the big practical takeaways? Why would a team go through the effort of adopting Kubernetes compared to those older methods? What's the real payoff?
The payoffs are pretty substantial. First, it just means simplified management. Automating all those repetitive, error-prone tasks frees up developers and operations folks to focus on building better software, not just keeping the lights on. And it's not just automating tasks, it's simplifying how teams think about deployment. It gives you a consistent way, a standard API, to deploy and manage applications, regardless of the underlying infrastructure.
That's a really interesting point, a common language for deployment.
Exactly. Then, as we hit on, portability and consistency. Build once, run anywhere reliably. Faster development cycles, fewer bugs hitting production, that's huge. You also get genuine high availability. Because Kubernetes is constantly monitoring and automatically replacing failed components, your applications become much more resilient to infrastructure problems. Users see less downtime.
Makes sense.
And related to efficiency, resource optimization. You use your hardware better, which often translates directly to cost savings, especially in the cloud. It allows for dynamic scaling based on actual need, not just guesswork. It really changes how you plan and budget for infrastructure. And lastly, don't underestimate the ecosystem support. Because Kubernetes is so popular and open source, there's a massive community around it. Tons of tools, integrations, documentation, and support available. You're building on a very solid, widely adopted foundation.
Okay, that makes a compelling case. So, given all that, when is Kubernetes really the right tool for the job? When should an organization or a project team seriously look at investing the time and effort?
Yeah, it's not for everyone necessarily, but our sources point to a few clear scenarios where it really shines. First, if you're building with microservices, trying to manage dozens or hundreds of small independent services manually, that gets incredibly complex, fast. Kubernetes is almost purpose-built for that.
Right, orchestrating all those little pieces.
Exactly. Also, any application that needs high availability and serious scalability, think large web applications, APIs, services where traffic can spike unpredictably. Kubernetes handles that dynamic scaling beautifully. Teams really pushing DevOps practices, continuous integration, continuous delivery. Infrastructure as code Kubernetes provides the automated API-driven platform that makes a lot of that possible. And it's a big one today. Multi-cloud or hybrid cloud. If you want to run applications across AWS, Azure, Google Cloud, and maybe your own data center, Kubernetes provides that consistent layer across them all. Portability is key there.
That multi-cloud aspect seems increasingly important. But, you said it's not for everyone. No tool is perfect. when might Kubernetes actually be too much? Or what are the main hurdles people should be aware of?
That's a really important point to make. It is powerful, but it comes with baggage. The biggest hurdle is the learning curve. It's complex. There are a lot of concepts, a lot of moving parts. It's not something you just pick up in an afternoon. It requires a real investment in learning.
So maybe not for a quick, simple project.
Probably not. It could definitely be overkill for small, simple applications. A basic website, a single monolithic app that doesn't need massive scale or complex orchestration. Using Kubernetes for that might introduce more complexity than it solves. A simpler deployment method might be totally fine and much easier to manage.
Right. Don't use a sledgehammer to crack a nut.
Pretty much. And related to the learning curve, there's the initial setup complexity. Getting a cluster up and running correctly, configuring networking, security. It's more involved than just deploying to a single server or a simpler platform as a service. But, and this is the key takeaway for those complex distributed applications that need scalability and resilience, the flexibility and reliability Kubernetes offers are often unmatched. The upfront investment pays off significantly in the long run for the right use cases.
Well, this has been a fantastic journey. We've gone from the sometimes chaotic world before Kubernetes, understood its core parts, and seen how it tackles those old problems head-on through orchestration and automation. It's really clear why it's become such a cornerstone technology.
It really is. And what's truly interesting, I think, is that even though Kubernetes itself can seem complex to learn, its ultimate goal is actually simplification. It simplifies how we operate complex software systems reliably at scale. It shifts the focus away from managing individual machines, babysitting servers, towards managing the application's desired state, letting the system handle the details. And that raises a fascinating question to ponder, doesn't it? As more organizations adopt this automated, containerized world, how will it continue to change the actual day-to-day roles and skills needed for developers and operations teams in the future? What does that evolution look like?
That is a great question to think about, a real shift in focus. Well, hopefully this deep dive has given you a solid foundation for understanding Kubernetes. It's just the beginning, of course, but a crucial starting point. Thanks for joining us.